So yesterday completed the your volumetric strain as well as relation between principal stress and the principal strains you have studied, and one important conclusion you have made that under plane stress condition, plane strain condition will not result, and vice versa. That is, similarly under plane strain condition, plane stress will not result now. But this statement is not valid in presence of the cork now, because Poisson's ratio is 0. When Poisson's ratio is 0, lateral strains are 0, only longitudinal strains are going to be there. Then in that case, under plane stress condition, plane strain condition will result, and vice versa. So I have given some question for practice from the workbook. Chapter number 1. Question number 23 is C. And 34 is 0.2. Chapter number 7. Chapter number 7. Question number 21. Answer is A. And question number 26, yesterday already discussed, is A. Then question number 42. It is 100.05. And second answer is 99.99. $99.9875. Okay. So some students are going to get a doubt. This question number 42 as well as question number 23 that I am going to discuss. 23 as well as 42. Chapter number 1, 23, some friends are already getting a doubt. Question number 32. Which question number, which chapter, my dear friend? 34. Yesterday I had done the same question, question number 34. Who is asking that now? Narang. Probably yesterday you are not attend the classes now. That's why you are getting a doubt in 34. 35 I had done the same question in the class now. Why you are getting a doubt now? There may be a doubt in 42 and 23. 42 and 23 they are going to get a doubt that I am going to discuss. What is given in the question now? What is mentioned? A circle of 100 mm diameter is drawn on a steel plate. Drawn on a steel plate. Which is loaded as shown in the figure. Diameter of the circle is given as 100. 5 stand for the so because of this loading condition, the circle is deformed into ellipse. The circle is deformed into ellipse. Now is asking what is the major axis and the minor axis. Because of this loading, the circle is going to be deformed into ellipse. Now is asking what is the major and the minor axis. So this is a major axis and the minor axis. I have assumed this is a position. I don't know whether this major axis is going to be what now. I have assumed about the major axis here now. But the actual position is going to be known only after calculating the location of the major principal plane. But in this objective question is asked only major and minor axis. So what is given in the question now? State of stress is given. You know sigma x, sigma y, tau xy. With this one you have to calculate the principal stresses. First calculate the principal stresses now. So this is a major axis. Major and minor axis. But if you want to get the location of the major and minor axis, then you have to go for the first method should be used it now. That is, first you have to find out the plane location, then you have to substitute that theta value in the equations. But in the question is asking only major and minor axis, then directly can go for the second method now. But if you ask location, first you have to find out the plane locations, then you have to substitute the theta value in the normal stress equation now. So here directly principal stress are 1 by 2 sigma x plus sigma y, 80 plus 20. Four tau xy square. check it. As per my expectation, should be 100 and 0. 100 and 0. Then epsilon 1 is equal to 1 by E sigma 1 minus sigma 2. But this is what now? Change in diameter to virginal diameter, delta D1 upon D1. Young's modulus is given. And Poisson's ratio initial is 100. So you are going to get it 0.05 mm. So major axis will be then epsilon 2. Sigma 2 is 0. Is a negative. Is a negative. So minor axis will be yesterday you already shown it, no, my dear friend? Gupta Amshi Kumar. Now is a plane stress condition, but what about the epsilon 3? Epsilon 3 0 or non-zero? Epsilon 1 is there, epsilon 2 is there, but epsilon 3 is going to be non-zero. It's the uniaxial state of stress condition. What now? It's the biaxial state of stress condition only, but the strains are what now? Principal strains are 3. Epsilon 3 is not 0. Epsilon 3 is non-zero here now. Sigma 3 0, but epsilon 3 is not 0 now. Sigma 3 0, but epsilon 3 is not 0. But generally this is about a conventional question. If the same question is given for conventional 20 marks now, they will ask the location of the major and minor axis also. We are getting only major and minor axis length now. But if you ask the location, what should be the first step? No, you should not use this now. First you have to find out your principal plane locations. You have to find out now. That is tan 2 theta equal to 2 tau xy by sigma x minus sigma y. Then find out the principal stress. Then you can go for this now. But since the objective question, we ask only major and minor axis lengths now. Mr. Guptamshu Kumar, probably you have gone through the lecture just like about a movie now. Yesterday I already done the 2 questions, I done it now. Under plane stress condition, we will not get a plane strain, a rectangular plate. In that case, what you have done it now? We got only sigma x and sigma y. But epsilon z is not 0. We have already done a question and you are asking, sir, I have gone through the lecture 2 times, it is not clear. Take an example now. Already I have done it now. How many questions I had to do it now? Please don't waste your time going through the lecture so many times now. But when you are attending a lecture itself, you focus 100% now. ध्यान से सुनो. Keep your body and mind both are towards the lecture. Otherwise, your time is not sufficient now. Already attend the lecture just like a spectator. Then afterwards once again going through. Where the time is there now? Only you have to go through the lecture. If any portion there is a query is going to be there now. When you have any queries, you underline it when in your notes itself. And when you are revising that notes, if you are getting any query, then that you have to go through that lecture, that portion only. 6.5 hours lecture, once again if you want to go through it now, it will take more time now. Means 13 hours is going through the only to go through the lecture itself now. Where is the time for revising the concept as well as practicing the questions now? And where the other subjects also you have to do it now. Not only strength of material now. 10 hours you have to spend first towards the strength of material every day, and 2 hours for the other subject now. Every day 12 hours preparation is required. 10 hours for, if you are spending the 6.5 hours or 7 hours towards the online lecture now. 3 hours for 1 hour to revise your notes and 2 hours for practicing the questions. And 2 hours should be what now? Revising the subjects which are already completed. So always every day revision is required. The 2 hours, 1 hour for one subject, 1 hour for one subject now. If you are already having a short notes, that has to be revised it now. Otherwise, practice the questions now. Don't waste your time now. Don't go through the same lecture several times now. So go through the portion of the lecture only where you are having a query. Now we'll come to the chapter number 1, question number 23. This question is given in Civil Service 1997, but the same question was repeated almost after 10 to 12 years, after 10, 12 years now. Maybe 2010 or like that, the same question was there in the engineering service paper now. Initially it was given in the Civil Service paper 1997. Maybe around 2010 or 2011, I not remember exactly. The same question as it was given in the engineering service paper. And this question some students are going to get a doubt. So I know where the students are going to get, the majority of the students are going to get it out. That question I am going to do it now. But the question which I already done it, same thing for formula substitutions, then we will not discuss now. By chance your answer does not match now, you cross check your, once again I have already given the answer, already clearly mentioned. If you are getting B, I have given A. Once again you can cross check your solution. If anything is new, definitely I will discuss now. If your calculation mistake, I will not do it on the board now. I don't want to waste the time now. You are not alone. There are so many students are there now. We already done so many questions in the class now. And one friend is telling, who is this now? Mr. Guptam Kumar. Sir, under plane stress condition, plane strain condition will not result, sir. Explain with example. I cannot understood after seeing second time lecture now. That is your mistake now. You have not gone through the lecture properly. And another friend is what? Sir, your teachings are great, sir. I am able to solve all the questions correctly in first attempt. All questions are based on concept till taught without a single error. The contact number will be shared only after the end of the subject now. After the end of the subject, the contact number is going to be shared. On the last day, I am going to give my contact number now. When your friend Rajanshu is able to do all the questions correctly, you can also do all the questions correctly. Once again I'm mentioning now, please focus, pinpoint focus required when the lecture is going on. Then only your concepts are clear. Then 6 hours of lecture you can revise your notes within 1 hour now. Otherwise, if you are going to attend my lectures just like about a movie or like this now, just like a spectator, not focusing now, then the remaining time only to once again go through the lecture only. Time is not sufficient now. Do a smart work. Do a smart work. Focus while the lecture is going on. And if any doubts are there when the lecture is going on now, I can ask directly during the break time, or when where break is going to be there, or after the end of the class now. Then still, if you have anything about a particular topic, a doubt is there, the only that portion you have to go through the lecture once again now. Do a smart work. So the remaining time, already 7 hours are went for only attending the online lecture now. Then you are left out with only 5 hours now. So that 5 hours you have to for practicing the questions, revising, practicing, as well as the another subject preparations are required. Don't waste your time now. We are not attending only for GATE strength of material. You are appearing for GATE 2023 for all the entire mechanical engineering. 4 years of syllabus, so many subjects are going to be there now. So I am going to go through the question number 23. A bar of elastic material is subjected to a direct compressive stress sigma 1 in the longitudinal direction. A suitable lateral compressive stress sigma 2 is applied along each of other 2 lateral directions to limit the net strain each of the lateral direction to half the magnitude what it could be under sigma 1 acting alone. Then what the value of sigma 2? Initially only sigma 1 is there now, compressive stress now. So it is a uniaxial state of stress. Actually stress cannot be applied. They are all incorrect wording now. Stress cannot be applied. Load is applied. In the question mentioned what stress is applied is incorrect now. Load is applied. So initially axial compressive load is applied now. So when you apply a axial compressive load, what happens now? Length will decrease and diameter will increase. Under uniaxial state of stress, you are going to get the triaxial state of strain. When load is applied in one direction, stress is there in one direction, strains are there in 3 directions. One longitudinal strain, 2 lateral strain. Now, what the next one is given now? When you are applying a load like this, now length will decrease, diameter will increase, cross-sectional dimension will increase. To prevent this increase in diameter, to prevent this increase in cross-sectional dimensions, we are going to apply a what now? A compressive load. Length is decreasing, diameter will increase. Now, if the length is decreased by diameter, what? To prevent the decrease in diameter, to prevent the increase in diameter, we are going to apply a compressive load in y and z direction. That is the triaxial state of stress. Now what is asked the question now? What is the stress developed in y and z direction? If the strain in what now? Y and z direction, the strain in y and z direction is equal to, that the lateral direction means y and z direction. The strain in y and z direction is equal to half of the strain in y and z direction when axial load is acting alone. First case is about a uniaxial state of stress. First case is a uniaxial state of stress, and second one is a triaxial state of stress. Some students are going to go through that question 10 times. There is no meaning now. Every question diagrams are not given. First go through the question, try to indicate the given data in the form of a rough sketches. What is given? What is given? Try to indicate the given input data in the form of the rough sketches. Then you write down what you have to write down. You already know the equations. But if you go through that question 10 times, you read it now, you will not get it now. So once you understood now, try to put the given data in the form of a rough sketches now. Load is applied in the compressive load is applied in the longitudinal direction. So because this one what happens, length will decrease and diameter will or cross sectional dimension will increase. It is a uniaxial state of stress and triaxial state of strain. Now to prevent this what the increase in cross sectional dimension, to prevent this increase in, now you are getting what longitudinal strain is there, lateral strains are there. So to prevent this lateral strain, what you have to do it now, you have to apply a compressive load. So what is given in the question now? The first case now, when Px acting alone, that is sigma 1 acting, due to this one the stress is given as a sigma 1. So to prevent this increase in cross-sectional dimensions, we have to apply a compressive load. Now this will result in what? A triaxial state of stress. So here you are going to get a, what is condition is given now? The stress due to Py and Pz, the stress due to Py and Pz is given as sigma 2. Now you have to determine the sigma 2 value. You have to prevent the sigma 2 value such that the strain in y and z direction equal to the strain in y and z direction when Px acting alone. So here you are getting uniaxial state of stress. This stress is given as a sigma 1. But how many strains you are going to get it? The triaxial state of strain. What the epsilon x is called now? Longitudinal strain. What the epsilon y, epsilon z are called now? Lateral strains, which is equal to minus of mu multiply by, so this value will be state of stress a uniaxial, state of stress a uniaxial, but state of strain is going to be triaxial. State of strain is a triaxial. Now here what you are going to get it now? Load is applied in 3 direction means you are going to get a triaxial state of stress. The stress due to Px is sigma 1. The stress due to Py and Pz is given as sigma 2. Now the triaxial state of stress. Strain is also triaxial state of strain. Now what is asking the question now? In this question, determine, this value is also given as sigma 2. Determine sigma 2 if, in this case, shall I use the longitudinal strain, lateral strain, or total strain? Total strain. The strain in y and z directions, strain in y and z directions is equal to half of the strain in y and z direction when Px acting alone. Half of the strain in y and z direction. When that's all. Now you can report now. The triaxial state, what the epsilon y and epsilon z. How to write down the epsilon y? 1 by E sigma y minus this value is half of the strain in y and z direction when Px act, what the strain in y and z direction when Px acting alone now. Now you can substitute it now. 1 by E will get what the sigma y value now minus sigma 2. What the sigma x minus sigma 1. What the sigma z minus sigma 2. If this condition should be satisfied, the stress in y and z direction should be this much now. So this will be the answer for this question now. You already know equation, but which equation you have to use it? The first you put this diagrams like this in rough sketches. Don't waste your time. Don't use a scale, pencil, eraser, etc. Draw with a rough hand now, with your free hand. Here you can use the, these two are called as what, a longitudinal lateral strain, but here we cannot use the longitudinal lateral strain. You have to use the total strain. So what the conclusion here now? Now you can see load is applied in one direction. So far what you have studied now, when the load is applied in one perpendicular direction, stress is there in only one direction, but the strains are there in three directions. That you have studied the first day when you are studying the difference between the strength of material as well as the engine mechanics. When the load is applied in one direction, stress are developed only in one direction, but the strains are developed in three directions. But the question is like this now. When a load is applied in one perpendicular direction, is there any possibility of stresses develop in other two direction? When a load is applied in one direction, assume the x direction, stress is there only in x direction, stress in y and z direction is 0. But is there any possibility when the load is applied in x direction, is there any possibility stress are developed in y and z direction? What the answer now? Possible only when now? When the strains in what y and z directions are prevented either completely or partially. So why you are getting the stress in y and z direction here now? Why you are getting the stress in y and z direction now? Because the strain in y and z direction is prevented either completely or partially. So generally the standard question will be there now. Based upon this conclusion only they are telling what now? Strain is a function of the, strain is the cause of the stress. Strain is the cause of the stress. So when the load is applied in one perpendicular direction, stress are developed only in one perpendicular direction, in the direction only. Other two directions stress are going to be 0. But when the load is applied in one perpendicular direction, if the stresses should develop in other two perpendicular direction, the condition is the strains in two perpendicular direction should be restricted either completely or partially. In this case what now? Why sigma y and sigma z 0? The strain in y and z direction is permitted or restricted? Now permitted. But here load is applied in one direction. But why you are getting the stress in y and z direction? Because the strain in y and z direction is restricted partially, not completely. Not partial, not completely. Partially is prevented now. So this is once again I am repeating now. When the loads are applied in one perpendicular direction, stress are developed only in the direction. Other two perpendicular directions stress are 0. But when the load is applied in one perpendicular direction, if the stresses should develop in other two perpendicular direction also, the condition is the strain in two perpendicular directions to the direction of the load. When the load is applied in x direction, the strain in y and z direction should be prevented either completely or partially. Based upon this conclusion only what they are telling what now? Strain is cause of the stress. Strain is the cause of stress. But that is not every time now. Now you can see y and z direction strain is there, but there is no stress here now. Y and z direction strain is there, but y and z direction stress is 0. But here y and z direction what? Stress is there because of what now? Strain in y and z direction is prevented partially. Now sometimes the same question will be modified like this now. Determine sigma 2 value if the strain in y and z direction is equal to this is about a permitted strain or restricted strain. Now, this is about a permitted. So that's the same question what now? Determine the what a sigma 2. If strain in y and z direction is restricted to 1/4 of the strain in y and z direction when px acting alone, determine the what now? Sigma y and sigma z, that is the sigma 2. If the strain in y and z direction is restricted to 1/4 of the strain in y and z direction when px acting alone, then in that case shall I take the 1/2 or 3/4? 3/4. 1/4 is restricted. Means how much is permitted now? 3/4 is permitted. So you have to equate to 1/4. But here nobody will make a mistake now, because half is restricted means half is permitted. But 1/4 is restricted means how much is permitted now? 3/4. Always you have to equate it to this representing permitted strain. Permitted strain. Here 1/4 is half is restricted, means automatically half is permitted. But the same questions, test series papers now, they are giving determine the sigma 2 value if the strain in y and z direction is restricted to 1/4 of the strain in y and z direction when px acting alone. If it is going to put the 1/4, you have to take the 3/4. 1/4 is restricted, means how much is permitted now? 3/4 is permitted. This is representing the what? Strain in y and z direction. So this is representing, but this question nobody is going to make a mistake. Why now? Half is restricted, means half is permitted. So this is representing what now? Here half is restricted, means half is permitted. When 1/4 is restricted, means 3/4 is permitted. So this question, most of them are going to make a mistake now. Suppose the same question is what? Determine the sigma 2 if strain in y and z direction is completely restricted. Strain in y and z direction is completely restricted. Means you have to equate it to 0. Completely restricted means what now? How much is permitted? 0 is permitted. Then you have to equate it to 0. Determine the what? The sigma 2 value if the strain in y and z direction is completely restricted. Completely restricted means how much is permitted? 0 is permitted. Then you have to equate to 0. So always you have to equate to the permitted strains, not restricted strain. When you are trying the solving the questions, try to understand what you are doing. But in the exam, what a slight modifications are going to be done it now. 1/4 is restricted, means everybody is going to put the 1/4. Sir, you are taken 1/4. Here, why you are taken half now? Because half is restricted, means half is permitted. Completely restricted means what now? You have to equate to 0. Because completely restricted means there is no permitted, is 0 now. You have to equate. Therefore, always you have to equate it to permitted now. When 1/4 is restricted means 3/4 is permitted. What is the problem, my dear friend? You are asking question number 21. Sinha, check it once again now. Two strain gauges fixed along the principal strain directions on a plane stress surface now. Epsilon 1 and epsilon 2 are given. Epsilon 1 and epsilon 2 is given and asking the largest normal and shear stress. I don't know what simple question why you are asking now. Epsilon 1 is given. E is given. Mu is given. And is asking what about the maximum normal stress and maximum shear stress. Can't you find out sigma 1, sigma 2? Epsilon 1 is given, epsilon 2 is given. Epsilon 1 is given, epsilon 2 is given, E is given, mu is given. And in the question is asking what now? I don't know what you are doing now. Sir, I am not getting the answer. Please explain. What should I explain here now? Straightforward question. Epsilon 1 is given, epsilon 2 is given, E is given, mu is given. Find out the maximum normal stress and shear stress. Can't you find out the principal stresses now? If you had done a calculation mistake, what I had to do it, my dear friend? That calculation also I had to teach it or what now? You try once again now. Sigma 1 equal to E 1 by E into sigma 1 minus mu sigma 2. Sigma 2 equal to. Here what the equation now? Yesterday already given now. Epsilon 1 is given, epsilon 2 is given, E is given, mu is given. Find out now. And what the sigma 2? All the equations are given and you are asking what now? Sir, I am not getting the answer, sir. Please help me. What should I help it now? Formula substitution. I will not teach how to use the calculator. I am going to teach only concepts now. Epsilon 1 is given, epsilon 2 is given, E is given, mu is given. Find out sigma 1 and sigma 2. If they are like in nature, maximum shear stress is what? The sigma 1 by 2. Unlike in nature, sigma 1 minus sigma 2 by 2. For this simple question, so many are what now? 3 or 4 friends. Sir, I am not getting the answer. Please help me, help me. What should I help it now? Yesterday I have already given the equation now. At the last I have written the same thing now. This equation should be used to determine the principal stress when the principal strains are given directly now. I am giving the questions only which are directly can solve from the class notes. I am not giving any questions for which you need a concepts now. Each and everything I discuss in the class now. I am doing the questions in the class with the different numericals. Only for your practice, I am giving the questions in the workbook now. Because you need a practice. If I am going to the workbook questions, you don't have the question for practice. So I am doing all the workbook questions with the different numericals. Before solving the question, try to refer your notes thoroughly. If you are not focused during the lecture now. Now these two question concepts are required. That's why I discussed it now. Even if you don't ask now, definitely I will discuss these two questions now. But this question directly formula substitution, equations are in the class. Epsilon 1, epsilon 2 is given. I don't know what you are doing now. In question number 26, chapter number 7, but just one small thing I want to ask. apart from what is solved, that sir, unit is given as kg per mm square. By default we have to think, obviously if it's given as what a kg means, it should be taken as a kgf only. Whenever the stress is given as about a kg per mm square means it's the kgf only. Stress is what now? Stress units are what now? Newton per mm square. Pascals I have already written kgf. So default whenever is mentioned as what now? Stress is given as what a kg per cm square or kg per mm square. That should be a kgf only. kgf. So you are correct, Mr. Swaraj. Now it is the triaxial or biaxial state of stress, triaxial state of stress. but it is assumed the biaxial state of stress. Why now? Z direction, the dimension is very small. Z direction, but this is about a plane. Yesterday somebody was asking now. Same question now. But this thickness calculation, what the first condition you have studied for plane stress condition now? One dimension should be very small in comparison to other two dimension. Thickness is what a very small. Length is what 1,000. Width is what 400. So length is how many times the thickness? 100 times. Thickness is 40. Width is 40 times now. So length and width are very large. But this thickness is coming in which direction now? Z direction. Next, what the other one here written now? The loading should be in such a way that the stresses in what now? Larger dimension direction should be very smaller in comparison to the stresses developed in the smaller dimension direction. Now you can see now, load in, this is what now? This load is in which direction? X direction, that the lengthwise. Load in Y direction, widthwise. But load in Z direction is very small. But you can see this thickness calculation. Thickness will come in the calculation of what now? Area of the X face or area of the Y face or area of Z face. This thickness will not come in the calculation of sigma Z. This thickness will not come in the calculation of sigma Z. So overall what happens now? This face. What the area of the Z face? Sir, this is Z face. Now area of the Z face. Load is in Z direction. But here which dimensions are coming now? Which dimensions are coming? Dimension in X direction and Y direction. Dimension in Z direction is not coming in this now. So load is very small. Area is going to be very large. Then automatically what a sigma Z is going to be very small. And this load is very large. Area is going to be very small. Then automatically sigma X and sigma Y are going to be very large. If this should be very large, load should be very large and area should be very small. Why this area is very small? Because thickness is small. But this thickness in what? In X direction or Y direction or Z direction? Thickness is in what? Z direction, not X and Y direction. Thickness is not in Z direction, not in X and Y direction now. So this will be 125 megapascals. What about sigma Y? What the load now? 800. Loading should be in such a way that the stresses in the larger dimension direction, that is what the length and widthwise, should be larger in comparison to stresses developed in the smaller dimension. So this load should be very large and area should be small now. What this area now? So it is 80 megapascals. So this is what now stress in smaller dimension. That is about now thickness Y. Thickness in which direction? Z direction. So this should be very small. If this should be very small, mean what the condition now? Load should be very small and area should be very large. This area is what now? L in B. But this area does not depend upon the thickness. Because most of students are going to tell what now? Sir, you have mentioned stress in the smaller dimension is going to be very small. Sir, when the dimension is very small, stress should be very large now. Stress in the smaller dimension is going to be very small. Sir, when dimension is small, area is going to be small. then stress should be more now. But the thickness, the dimension in the z direction, that the thickness will not come in the calculation of sigma z. The thickness will come in the calculation of sigma x and sigma y. This is 20 kilonewtons. What the AZ now? What the area? Now you can see now, this is very, very small. These two are very large now, but this is very small. Why this is very small? Because load is small and area is large. But why the area is large now? Length and width are very large, but thickness will not be there now. So now is the triaxial or biaxial state? Triaxial, but is assumed as the biaxial now. But the plane stress condition you have studied now. Plane stress condition is the condition here. Triaxial case should be assumed as a biaxial. Is a triaxial case, but if you want to assume as a biaxial, what the condition now? The stress in the smaller dimension direction should be very small in comparison to stresses developed in the larger dimension direction. Therefore, it is assumed as about a biaxial plane stress condition. But actually, the state of stress is what a triaxial. Now this is assumed as about now. Assumed as a biaxial now. Assumed as a biaxial. When this dimension is very small, it looks like about a plane. It looks like a plane. Is the assumed state of stress. But why assume like this now? Some students are about now, sir, syllabus is biaxial. Not like that now. Suppose this is going to be some 20 megapascal. We cannot make assumption like this now. Every triaxial problem cannot be assumed as a biaxial problem. If you want to assume the triaxial problem as a biaxial problem, the stress in one direction, that is what, a smaller dimension direction, should be very small in comparison to stress in the larger dimension direction. Is the assumed state of stress. Assumed state of stress. Somebody is going to consider this now. Somebody is going to consider, but finally answers are going to be same because this is very small. Suppose this is going to be 10 megapascal. We cannot neglect it now. It's a very, very small. That's why it is neglected now. This is the assumed state of stress. That is sigma z is very small in comparison to sigma x and sigma y. Hence sigma z is neglected. Can be neglected. But what is the reason now? Why sigma z is very small? What is the reason now? Because dimension in z direction here only everybody is going to get sir, when dimension is less, stress should be more. But the dimension in the z direction will not come in the calculation of sigma z. The dimension in the z direction will come in the calculation of sigma x and sigma y. And what the other reason now? Load in z direction. But what about the strain question now? Is a sigma 1, sigma 2, but sigma 3 is not 0. Sigma 3 is not 0. Even though you are neglected sigma z, we are neglected the sigma z, but epsilon z is not 0. In this case, what now? This is epsilon 1 non-zero, epsilon 2 non-zero, epsilon 3 is also non-zero. Z direction stress is 0, but strain will not be 0 because of what now? Because these two you are going to get a lateral strain. Because these two stresses in Z direction, what the strain is depend upon what now? Z direction, how many strains are there now? One strain due to sigma z, the longer strain. But due to sigma 1 and sigma 2, one lateral strains are there. So even though sigma 3 is 0, but epsilon 3 is non-zero. That only yesterday I done it now. 2 or 3 questions he had done it now. And one friend is asking, sir, you have mentioned a conclusion, but it is not clear for me. Take a question, you solve it now. Means under plane stress condition will not get a plane strain. Under plane stress condition will not get a plane strain. This will be a non-zero because mu is non-zero. If mu is 0, this is also going to be 0 now. So plane strain condition does not result under plane stress condition. Stress is about the plane stress. Only sigma 1 and sigma 2 are there. Sigma 3 0. But strains are there 3 now. But this is valid when mu is going to be non-zero. ठीक से देखो जी सूरज कुमार, the dimension in z direction larger, but the dimension in z direction thickness क्या ऑलरेडी आर रिटर्न नो? क्या देख रहे हो आपने? जेड डायरेक्शन में कौन सी डायमेंशन है? 10 है सर. जेड डायरेक्शन में डायमेंशन लार्जर बोल के लिख रहा है आपने. किधर लार्जर है? This 1000 is in which direction? X direction. 100 is in which direction? 400 is in Y direction. Z direction कौन सी डायमेंशन है? 10 है. 10 लार्जर है क्या? I have already given the diagram. I have given this one and is asking sir dimension in Z direction is larger sir. सुबह सुबह सो जा रहा है क्या क्लास में? अभी उठा क्या? Please don't sleep in the morning time now. Indians will not sleep around 9 o'clock in the morning, 9 o'clock. If you are getting a sleep during my lecture now, and every day you are getting what a sleep when 9 o'clock now. Indians will not sleep in the 9 o'clock or 10 o'clock now. And mechanical engineer will not sleep now. But if you are getting sleep when the lecture is going on 10 o'clock, 11 o'clock now. See the timing now. Suppose you are getting a sleep at 9 o'clock. Enter what a Google search criterion now. Which country people are sleeping at 9 o'clock. Then try to migrate to that country immediately. Then appear engineering services of that country now. You are not meant for to serve our country now. If you are going to be what to become as an officer now, your subordinates also will sleep now. And total country will sleep now. Don't sleep when the lecture is going on now. But I clearly have shown it here now and is asking, sir, dimension in z direction is larger, sir. Mr. Suraj Kumar. If that is whatever the 0.05 you write down, my dear friend, don't bother about that my calculation. Somebody is about a sigma that is 0.05, you can write down now. Maybe my calculation mistake may be there now. Whatever the value you are getting, that you write down now. But that obviously what now? Less. Probably I written 0.02, that is change it to 0.05. Suppose I'm not remembered, suppose by chance I written the 0.02, change it to 0.05. So complete this question now. A rectangular block determine the stress tensor and P1 and P2. Always we can apply the load. Stress cannot be applied now. Now how to find out the P1 and P2 now? How to find out the P1 and P2? Due to this one you are getting what? Either shear load or normal load? Shear load. So due to this one you are getting the X phase. We can assume some directions. X, Y, Z. This is a normal load. This will be what now? Shear load. Due to this one, which says you are going to get a tau xy. Tau xy. And due to this one, you are going to get a tau xz, but P2 the unknown. Then how to get the P2 and P1 now? Due to this one, you are getting a tau yx. Due to this one, you are getting a tau xy. So by equate the tau xy and tau yx, you can find out the tau xy. How to find out the tau xy? Shear force upon this area. Then once you know tau xy, then you can find out the what tau yx. Tau yx equal to tau xy, then already you know the area, then you can find out P1. And due to this one, you are getting tau xz, the tau zx. And how to find out the P2? Now due to P2, you are going to get it tau xz. So now equate the tau zx and tau xz, then you can find out the P2. What the area now? Then tau xy. Tau xy is the 200 kilonewtons. Is a positive. This is anti-clockwise. Negative. Next, tau xz. P2. P2 the unknown. Then it sigma y. Area of the y face minus 200. What the area of the y face now? 600 into 200. that is compressive. Now tau yx that is P1 upon area. Now to find out the P1, now these two should be equal and like. So equate the tau yx is equal to tau xy. Tau yx equal to tau xy. Now equate it to tau xy. What the tau xy you are getting now? 2.5 into 12 into 10 power 4. $30. 300 kilonewtons. Next, sigma z. $500. What the area of the z face? 600 into 400. 50 upon 24. Next, tau zx. That is 200. Now to get the, so this is tau xz, sorry, the tau xz. Now equate the tau xz and tau zx, then you can find out P2. Tau zx is equal to tau xz. Tau zx here getting 10 by 12. But the tau xz you got it now. From this one you can find out the P2. Now which are 0 now? Tau yz and tau zy are 0. Tau yz and tau zy are 0. You can find out the, you can write down the matrix now. Now you can show the stress tensor now. This is 1.25 sigma x sigma y 10 by 6 1.67 sigma z 50 by 24 2.083 then tau xy So here shear force is what the upward will be there now. Then this shear force and here what down. These two are forming a couple in what which direction? Anti-clockwise. Then resisting shear force will be a clockwise. That's why I change it what a downward direction now. This shear force is forming a couple in which direction? Anti-clockwise. Then resisting shear force will be clockwise direction will be there. So stress will be always in the direction of the resisting force. Always stress will be in the direction of the resisting force. So since this is what now? Giving a couple in anti-clockwise, then stress will be in clockwise. That's why shown in the downward. This is a downward. This is a tau xy downward. Next, what about this shear force now? This shear force forming a couple in anti-clockwise. Then resisting shear force a clockwise. That's why it is going to be towards left side. Towards left side. And the back side face it will be what? Towards right side. On the front face towards left side and the back side face towards right side. Now this will form a couple in which direction? Clockwise. And here this shear force P2. P2 is forming a couple in which direction? Clockwise. P2 is forming a couple in clockwise. Then resisting shear force anti-clockwise. That's why shown like this now. So on the back side face what now? So here is the upward. Then here you are going to get a, here is what the outward, inward or outward? This is the inward. Is the right side X face and the left side X face will be outward will be there now. Here on the right side X face the inward and here you are going to get a outward will be there now. This is tau xy. Is a sigma x. This is tau xz. This is what now? This is tau xy. Sigma y. This is sigma z. So how to show the matrix now? Sigma x is 1.25, sigma y minus 1.67, sigma z 2.083, and what about tau xy? 2.5. This minus 0. So this will be the stress tensor. So these two will form a couple in what now? Anti-clockwise. And here it's going to be upward will be there now. So this downward and here upward will be what? A clockwise will be there now. So tau xy is the clockwise and tau yx is going to be anti-clockwise will be there now. That's why generally they are going to show the matrix. Triaxial case what now? Matrix is going to be shown. Biaxial case generally graphical representation. For triaxial always the matrix is going to be used now. Now to decide the stress now cut it. If we cut it now. Now these two are forming a couple in which direction now? Vertical plane clockwise. This is what now? Due to this one you are going to get tau xy. Tau xy. These two are forming a couple in which direction now? Clockwise. In vertical plane. Then resisting shear force will form a couple in anti-clockwise. Same concept you have studied, stress concept now. This is about the cut surface on right side, is a cut surface on left side. So this is when you have pulled it like this, what you have studied, resisting force is going to be what now? When you are going to pull it like this, resisting force is going to be towards left side. So now these two are forming a couple in clockwise, then resisting shear force will form a couple in anti-clockwise. Then here it is going to be so your stress will be in which direction now? So these two are forming a anti-clockwise. These two are going to form a couple in anti-clockwise. Same thing what when you apply tensile load here now. Is a resisting shear force. F is a resisting shear force. When I am going to pull it like this, is a tensile load. Then what about the resisting force here now? N means normal. S means what? A shear. Therefore, due to this one, you are going to get a stress at tensile. But here what now? This Fs and this Fs is forming anti-clockwise. These two are forming an anti-clockwise. Now you can see now this is towards left side. towards right side, then this will be towards left side will be there now. So always what the stress will be in the direction of the resisting force. Resisting force are always similar to the load, opposite direction. The shear force, the shear force. So these two are P and P forming a couple in what a vertical plane clockwise. And this Fs and this Fs are the resisting shear force. So these two will form a couple in anti-clockwise. The stress is going to be what? The tau xy is going to be anti-clockwise will be there now. And this is a normal load, normal tensile load towards right side. So it is also normal load. But towards left side is there now. Both are in what? A tensile load only. It's the towards right side, the towards left side. So clearly mentioned stress will be always in the direction of the resisting force. Resisting force always similar to the load but opposite direction. Stress is what? Resisting force always similar to the load, opposite to the direction. And here reaction is what? Q. S means resisting shear force. N means is a resisting normal force, is a resisting shear force. This is Z phase, this front face is Z phase. This is what a tau. What is 0.83? What is the 0.83? Tau Zx will be there now. Tau Zx. 0.83 the tau Zx. Otherwise, you can show like this now. This is what now? Tau xy clockwise, and this is a tau yx anti-clockwise. This is what a tau xz horizontal plane anti-clockwise, and tau zx is what a horizontal plane clockwise. This is going to be clockwise, and this is sigma x, sigma y, sigma z. Otherwise, you can show like this now. So this is about a matrix representation. Now tau xz is what anti-clockwise. That's why you have taken minus. And tau xy is what a clockwise. That you have taken. That's why you have taken positive in the matrix now. Is the tensile, compressive, tensile. So how many shear stress are 0 now? Tau zy 0, tau yz 0. This is a clockwise, anti-clockwise, my dear friend. This is a clockwise. How it is anti-clockwise? This is a clockwise. Tau xy is a clockwise. That's why I have taken a positive. How it is anti-clockwise? Harshavardhan. How tau xy is what anti-clockwise now? Tau xy is a clockwise. How it is anti-clockwise? Now write down the next concept. Load. Now we are going to study we have studied on the cross section there are 4 loads are there. Axial load, shear force, bendiment and twistment. Now we are going to discuss how to calculate the axial load, shear force and bendiment and twistment. For that one we need the loading concept is required. Now if this is going to be clear, then you can do the remaining questions now. First read on the definition of the word. This also you have studied first day when you are studying the difference between strength of metal engine mechanics. Load is defined as the external forces or the couple to which a component is subjected. Read on the definition of load. Load is defined as the external force or a couple to which a member is subjected. To which a member is subjected during its functionality. Load is defined as an external force or a couple to which a member is subjected during its functionality. Always during the functionality, some external forces and the couples are going to be there now. Couple is also formed due to two equal parallel opposite forces. Now you are sitting on a chair. What the functionality of the chair now? To support the person who is sitting now. So during the functionality of a chair, what type of load is acting now? Your weight is acting externally onto the chair. So your weight will become as a load now. Your weight will become as a load onto the chair. Now what are the examples here now? Weight of a member. Weight of a member with respect to another member. What is the meaning of this now? In the chair example, which one is considered a load now? When you are designing a chair, which one should be how many weights are there now? Person weight as well as the what now? Weight of the chair is there now. But weight of the chair is not considered. Which one is acting externally now? Your weight is acting externally. So in the design of the chair, the weight of the person is considered as a load. Self weight is going to be neglected. That only is studied assumptions now. Self weight is going to be neglected. Why? Means it is not external. What the load definition now? Load definition is the externally applied force. Self weight is not acting externally. So here what the conclusion now? Weight of a person with respect to chair. Weight of a person with respect to chair will become as a load now. Similarly what now? Shaft. On a shaft, which one is mounted? Now pulleys and gears are mounted. So when you are designing a shaft, which weight should be considered? Now weight of the pulley and weight of the gear. Weight of the pulley and weight of the gear are acting externally onto the shaft. So here what should I read now? Weight of a pulley with respect to weight of with respect to shaft now it is a load, or weight of a gear with respect to shaft is a load now. Self weight is going to be neglected because the definition of the load is about now externally applied forces. External force are a couple to which a member is subjected. Next, centrifugal forces. Inertia forces, friction force, if you go for structures, wind force, if you go for a belt tensions, belt T1 and T2 tensions are going to be there now, belt tensions. Next, bending and twisting couples are going to be there now. Bending and twisting couples. In the force are classified in two type of forces. One is about now surface force and body force. 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 What is the meaning of surface force now? These are distributed over the area of a surface. Surface means a 2D. It will have the area. Body means what now? Volume. So these forces are distributed over the area of that surface. And this is what now? Distributed over the entire volume. So self weight is the example for body force. Self weight is the example for body force. So weight of the chair is distributed over the entire volume of the chair. But your weight is acting on the surface of the chair. That's why you are considered what now? So default load means what? The surface forces. Load means a surface force. Always the externally applied forces. Always the externally applied forces, surface forces. So in the entire strength of material and the machine design now, the surface force is considered the load now. These are distributed over the area of that surface. Area of that surface. Distributed over the volume. Body means about the solid. Solid means have the volume, or the volume of the body. How to get a self weight? Self weight is what? A weight density multiplied by volume. Weight is going to be what? A self weight is given by weight density into volume. So generally what the example for surface forces now? All the externally applied force. All the externally applied force are the surface force. So your weight is acting on the surface of the chair. But weight of the chair is distributed to the entire volume of the chair. All the externally applied forces. Here self weight. Self weight is an example for body force. Self weight is an example for body force. Sir, then why you are neglecting the self weight? Self weight is what are distributed over the entire volume. The stress strain deformation. The stress strain deformations are very smaller in comparison to stress strain deformation due to body force are very smaller in comparison to surface forces. That's why entire what now? Your strength of material. Default we are neglecting the stress strain deformation due to body force. If clearly mentioned, consider self weight effect, then you are going to consider it. Otherwise always is going to be neglected, because the stress strain deformation due to body force are very smaller in comparison to stress strain deformation due to surface force. We are going to study now. If a bar is going to be pulled, if a bar is pulled with a load of W, what the elongation of this bar? WL by AE. And what the elongation of this bar due to self weight? WL by 2AE. If this bar is pulled with a load of W, axial load of W, what the elongation? WL by AE. But next, the weight of this marker is what? A W. So what the elongation of the marker due to self weight? WL by 2AE. In both the case, load is same, length is same, area is same. But here this W is applied externally. So what the elongation of this marker? Now WL by AE. But due to self weight, it is going to be WL by 2AE. So always the chance of failures are going to be more the surface force when compared to body force. Same thing what now? A person is standing on a beam. A person is standing on a beam. Next case what? The same person is sleeping on the beam. When it's sleeping on the beam, it will become as a distributed load. So always the body force is treated as a what now? Distributed load. It's distributed over the entire volume. Self weight is also distributed load. It's distributed over the volume. So when it's standing now, when it's standing, it is treated as what now? Constant point load or surface force. But when it's sleeping on the beam, it's distributed over the entire volume of the beam now. So chance of failures under distributed loads are less when compared to externally applied force or concentrated loads now. So default in strength of material, we are going to neglect that find the input data. Whenever you want to find out the self weight, what the self weight, how to write down now? What is gamma? Gamma is the weight density, volume, area into length now. So always what to find out the self weight, what is the data is required now? Gamma. So gamma is not a input data. Gamma is not a input data. Always strength of material problem, what the input data you have studied now? Dimensions the input data. I know the area, I know the length. Next, E and mu. But gamma is not a input data. By chance in the question gamma is the weight density. Gamma is the weight density, Newton per meter cube. Rho is generally represent the mass density. Rho is the mass density, kg per meter cube. So if whenever in the question, if they have given any data with respect to sulfate, that is weight density or directly sulfate or weight per unit length is given, then you have to consider effect of the sulfate. Otherwise, default sulfate effect is going to be neglected. Most of the question, because the entire strength of metal, what you have studied assumptions now. First day, no, sulfate effect is neglected, but some question clearly mentioned what now. Consider the effect of sulfate. Otherwise, what a gamma is given. Once gamma is given, or sulfate is given, or weight per unit length is given, then you have to consider effect of the sulfate. Otherwise, always it is going to be neglected. Should be considered when in metal subjects, sulfate effect should be considered when any data, that is what a rho means mass density, gamma weight density. Somebody is going to tell us shear strain. You have to see the units. It is a Newton per meter cube. This is a kg per meter cube. Weight per unit length, or directly sometimes sulfate is given. Any data with respect to sulfate as given as the input data. But generally most of the time this data will not be there. Always what the input data you have studied, no, dimensions are input data, E and mu are input data, Young's modulus and Poisson's ratio input data. But why is neglected mean what the answer na? Why you are neglecting the sulfate? Sulfate is a distributed load. So always the stress strain deformation due to sulfate are distributed load. Stress strain deformation due to distributed load. Always less when in comparison to stress strain deformation due to surface forces. So they will become as just like a constant load now. So this is always a distributed load. Distributed load. But design is always neglected. design always is neglected. Why? Design means you have to calculate the dimensions. Design of a shaft. Design of a shaft means you have to find out the diameter of the shaft. What the design you have studied, now you have to find out the what now? Design means ultimate aim of design is to calculate the, developing a drawing. But academic point of what you have studied now, finding out the dimensions. When diameter is unknown, area is unknown. When area is unknown, volume is unknown. When volume is unknown, self weight is unknown. So always design what now, self weight is neglected. But strength of material dimensions are there now. But additionally, what is the data is required now? Gamma is required. But in machine design, whenever you are designing any component, design means you have to find out the cross-sectional dimensions. When the cross-sectional dimensions are unknown, area is unknown. When area is unknown, volume is unknown. When volume is unknown, self weight is unknown. So that's why design of any machine component, always the self weight is neglected. Then how your design is safe? Self factor of safety. You have studied the factor of safety, always what now? When you have studied the assumptions you have studied now, always the factor of safety is considered in the design because of these assumptions only. In design we have make the so many assumptions. All the design calculations are based on strength of material equations. Strength of material equations are derived based upon so many assumptions. So strength of material equations will give the exact value of stress, strain, deformation when assumptions are satisfied. But all the assumptions are not practically satisfied. When the assumptions are not satisfied, then you will not get the exact value of the stress, strain, deformation. Then how your design is safe means what? A factor of safety. So always machine design what now? Self weight is neglected. Because design means dimension should be calculated. When dimensions are unknown, self weight is unknown. When self weight dimensions are unknown, volume is unknown. When volume is unknown, self weight is unknown. But how your design is safe means because of the factor of safety. But in strength of material, dimensions are known. But which data is not going to be there? No, gamma is not given now. If by chance gamma is given, then you have to consider. But why gamma is not given means what now? Already mentioned now. Deformations. Stress strain deformation due to body forces or self weight is going to be less in comparison to stress strain deformation due to externally applied force, that the surface force. That's why generally is going to be neglected now. Next, write down the classification of the loads. Somebody is asking, sir, is there any possibility self weight? Self weight never will act alone. Whenever a member is there, means what? There is a functionality will be there now. If a ceiling fan rod is there, self weight is there. Always self weight will be there. But any component, what? There is a functionality will be there now. There is no component without a functionality. And during the functionality, there are so many external force and couples are going to be there now. So always what during the functionality, some surface force are there now. Without surface force, only self-weight will not exist now. Without surface force, self-weight will not exist. If any member is not manufactured, or fabricated, there is one functionality there now. Why the shaft is manufactured? Because to transmit the power. Why the share is manufactured now? To support a person. So every component there is a functionality will be there now. Without functionality there is no use of that component now. And during the functionality always what now? Loads are acting now. During the functionality always loads are acting. Load means default the external forces now. External force and the couples are going to be there now. External force and couples are going to be there. So only self-weight case will not exist now. Only self-weight case will be exist now. So I'm coming to the classification of the loads now. Now I'm going to write down the classification here. This classification is going to be little bit lengthy. Try to write down horizontal. Generally, this board is not sufficient for me now. When I'm going to take the offline classes, I will occupy the entire board now. But now, because here the camera is going to be fixed and the space is going to be fixed for me now. So within this space only I have to write down. But for you what now? You can rotate your notebook and try to write down horizontally. It is a lengthy classification. Loads are classified. Based upon 3 parameters. Loads are classified based upon 3 parameters. First parameter is going to be with respect to time. With respect to time. Second one is with respect to cross section. With respect to cross section already I studied now. Cross section the plane perpendicular to longit axis. Cross section the plane perpendicular longit axis. And third one is going to be with respect to distribution of load. With respect to time, they are classified into static and dynamic loads. And with respect to cross section, they are classified into normal and shear loads. And with respect to distribution, constant loads and distributed loads. Let me write down the total classification. static loads and dynamic loads. Entire strength of material you are assuming as a static load. Most of the machine components are subjected to dynamic loads and static load, but most of the structural components are subjected to static load. Most of the structural components are subjected to static load. So most of the assumption whatever you have made in strength of material, they're all with respect to structural components. That's why most of the machine design strength of material textbooks, they are giving the examples of structural examples only. And most of the assumptions whatever is made while deriving the strength, they are all satisfied mostly with respect to structural example. Machine components is not satisfied now. That's why when you are going for machine design, slight modifications are going to be there now. And these two loads are further, static loads are further classified into dead load, dead load, gradually applied load. Gradually applied load. And this dynamic loads are further classified into impact loads, impact or what is the name now? Impact loads are shock loads or suddenly applied load. So I'm in the gradually applied load as a GAL. Is the short form I'm using now. Gradually applied load. And suddenly applied load you are using SAL. Suddenly applied load. Next, fatigue loads. Fatigue loads are what is the name now? Cyclic loads or variable loads. Fatigue loads or cyclic loads or variable loads. And these loads are further classified into this is what a very important topic for mechanical engineers now. And this chapter we are going to study separately in machine design now. A separate chapter 8 to 10 hours time is going to be taken for this fatigue loading now. It is very important for mechanical engineers now. Now fatigue loads are further classified into completely reversed loads. Completely reversed loads. Fluctuating loads. Fluctuating loads. Fluctuating loads. Completely reverse loads, fluctuating loads, and alternating loads. Alternating. So this is a classification with repeated time. But the second one is very important one with respect to cross section. What the normal load mean? What a perpendicular to that surface. But what the cross section? A cross section is surface perpendicular along its axis. Cross section the plane. Cross section horizontal plane or vertical plane or profile plane. Depend upon the member position. When member is horizontal, cross section in profile plane. When member is vertical, cross section in horizontal plane. When member perpendicular plane of the board, it is vertical plane. Cross section the plane perpendicular along its axis. So, if somebody will ask simply what the normal load means, what now? How many surfaces are there now? How many surfaces are there? Top surface, bottom, left, right, front and back. So many surfaces are there now. So normal load means what? If somebody will ask what the normal load? Perpendicular to given surface. Perpendicular to given surface. And shear load means parallel to given surface. Second one is what now? Shear or tangential loads. That's why you have studied. How many stress you have studied now? Due to normal load, normal stress. Due to shear load, shear stress. What is the name for shear stress? Tangential stress. Tangential stress. Now, but you are studying normal loads on what now? Normal load on a cross section. On a cross section, how many normal loads can be applied now? On a cross section, how many normal loads can be applied? First one is the what now? Axial load. axial load. Next, eccentric. Eccentric axial load. Eccentric axial load. Bending couple. Only this bending couple already is studied, axial load you have studied. But the bending couple is studied always perpendicular to cross section or along the longit axis. Axial load, eccentric axial load and bending couple. Somebody is called a bending moment. Every time bending couple is not a bending moment, already studied now. Bending couple will become a bending moment only at the extreme end. Now these two loads are further classified into tensile load. Compressive load. Tensile load and compressive loads. Next, how many shear loads are going to be there now? Transverse shear load, eccentric transverse shear load and twisting couple. So space is not sufficient for me, even though I written as what now, congested what now, but still the space is not sufficient now. So this I will draw it separately with respect to the direction of distribution of the load. Transverse shear loads. TSL. Always what the definition of a beam? Beam is a structural member subjected to transverse shear loads. What the transverse shear load you have studied now? Axial load is along the longit axis. Transverse shear load is perpendicular to longit axis. Transverse shear load, we are in the short form of TSL. Next, you are going to get an eccentric transverse shear load. Eccentric. Eccentric transverse shear load. Eccentric transverse shear load. Eccentric means cross section, means always centroids will be there. Eccentric means what now? That line of action of the load does not pass the centroid. Axial load means always pass the centroid. Eccentric means what now? The line of action of the load does not pass the centroid of the cross section. Centroid is always used for a cross section. Eccentric means it will not pass through the centroid. And next one is what? A twisting couple. They are using the short form of TC. Twisting couple, TC. The twisting couple already have studied parallel to cross section. Twisting couple is parallel to cross section, perpendicular longitude axis and about polar axis. Now these two loads are once again further classified into what now? Horizontal transfer shear load and vertical transfer shear load. You have studied the HCA and VCA. What is the meaning of horizontal transfer shear load? That will be along HCA. Vertical transfer shear load means along VCA. So these two are further classified into horizontal, HTSL, horizontal transfer shear load. So this will be along horizontal central axis. Same thing you are going to get about horizontal eccentric transfer shear load. Horizontal eccentric transfer shear load. Twisting couple. So overall, how many loads can be applied externally on the cross section? Cross section, how many loads can be applied? 6 loads can be applied. 3 normal loads can be applied. Axial load is applied, eccentric axial load is applied, bending couple is applied, transfer shear load is applied, eccentric transfer shear load, twisting couple. So on a cross section we can apply 6 loads externally. Out of them 3 normal loads, 3 shear loads. What the 3 normal load? Axial load, eccentric axial load and bending couple. 3 shear load, transfer shear load, eccentric transfer shear load, twisting couple. But some students will mention, sir, you have mentioned on the cross section only 4 loads. External we can apply 6 loads, but they are all equivalent to only 2 loads, 4 loads. We can apply externally 6 loads. 3 normal loads, 3 shear loads. 3 normal loads are the axial load, eccentric axial load, bending couple. 3 shear loads are transfer shear load, eccentric transfer shear load and twisting couple, but they are all equivalent to only 4 loads. What are they now? Axial load, shear force, bendment and twistment. We can apply externally 6, but they are all equivalent to only 2 loads. For example, eccentric axial load is equal to 1 axial load and plus 1 bending couple. Eccentric axial load is equal to 1 axial load and 1 bending couple. And transfer shear load equal to 1 shear force and bending moment. Now we can apply external 6 load, but they are all equivalent to only 4 loads. So that's why you have studied what now? On the cross section you have studied the only 4 stress: axial, bending, direct shear and torsional shear stress. Everybody is going to get it out. How many loads are applied? External means 6 loads. How many loads are possible on the cross section? Means 4. That is axial load, shear force, bendment and twistment. That we are going to discuss next now. Externally can apply 6 loads, but they are all equivalent to only 4 loads. Axial load, shear force, bendiment and twisting. Just now I give an example. Eccentric axial load. It is axial load only, but does not pass the centroid. So because of this eccentricity, you are going to get a bending couple will be there. And transfer shear load equal to 1 shear force and bendiment will be there now. And now this is further classified into this table. Probably when I started my profession, already mentioned 1994. So I started 1994. I started my teaching profession. When I started a machine design, I started this now. But year by year, I'm doing the modification in this load classification now, year by year. Because so many are now copying my table now, this one now. Whoever is going to be teaching they are going to write down this table, this classification now. So I cannot. My students itself, they are working as a faculty. Some of other faculties, they are all now copying this now. They reproduce the same now. Then I cannot stop them now. Then I'm doing the modification now. I'm doing the modification. Those who attend my lecture 2 years back, this table, this classification will not be there now. So year by year, I'm doing the modifications on this classification now. And with respect to distribution, constant loads and distributed loads. If the loads are acting on a cross section, it is called as the constant loads. If they are distributed over the entire length of the member, if they are distributed over the entire length of the member, is a distributed load. Entire member means all the cross sections. When the load is acting only on a cross section, it is called as a constant loads. But when the load is distributed over a entire member means what is distributed over the entire all the cross section is the distributed loads. So these are further classified into concentrated loads. Means they are concentrated only on one cross section. They are concentrated only on one cross section. Distributed means they are distributed over the entire member. Member means what? It will have the multiple cross sections will be there now. Distributed loads. This I mean the short form of DL. Distributed loads. Distributed load DL. Simple example I have wrote down. A person is standing on a person is standing, assume this is a beam now. It's a beam. A person standing like this, therefore this weight will become as about a constant load. So his weight is acting only on the cross section of only one cross section. But when the same person is sleeping on this what a beam, when the same person is sleeping, so his weight is distributed over the entire length of the beam, that is distributed over all the cross sections. Then it is called the distributed load. How many constant loads are going to be here now? Concentrated point loads and concentrated moment. Concentrated point load. Simple example, on a shaft a pulley is mounted. On a shaft a pulley is mounted. On the shaft which one is mounted now? Pulleys and gears. So the weight of the pulley or weight of the gear will become as a concentrated load. On a shaft a pulley is mounted with a weight of W. So that weight will become as what now for the shaft? Concentrated point load. But what about the weight of the shaft? Weight of the shaft is distributed. That will become as a distributed load. Is the shaft and my hand is what now? Marker is the shaft and my hand is the pulley. So the marker weight is distributed over its entire length. But the weight of the pulley is acting, over a cross section. That is a so weight of the pulley is taken as a concentrated point load. Weight of the shaft is taken as a distributed load. And next one is what? A concentrated moment. Concentrated moment. And these are further classified into UDL, uniformly distributed load. Uniformly distributed load. Uniformly distributed load. They're all going to be used in the SFD BMD now. Next, uniformly distributed load. Uniformly varying load. Uniformly varying load. UDL, UVL. Next one is what now? UDM, uniformly distributed moments. Uniformly distributed moments. UDM. UDL stands for uniformly distributed load. UVL stands for uniformly varying load. UDM, uniformly distributed moments. But mechanical application, you are going to come across these two only, UDL and UVL. Mechanical application, never you are going to come across the UDM. UDL means, UDL stands for uniformly distributed load. UVL stands for uniformly varying load. UDM, uniformly distributed load, uniformly distributed moments. So this is the overall classification of the loads now. Now you can see that table as well as this table. Definitely there is a slight modification will be there, Mr. Ankush. So one of your friend is already mentioned the same. Sir, I have seen the same classification from a faculty of another institute. He was ex-made the student and mentioned he made it all himself. That only I mentioned now. There is nothing wrong about now. Telling the teacher name now. I'm going to tell still what I'm a proud to student of one of VVS Shastri. I'm going to tell it. You can tell it what now. I learned all this thing, but I added my experience. You can tell it now. He has taught me about all the basics, but he has not done all this thing. Then afterwards, I done as per the students, I done so much of modification now. The students itself what they are telling, so I created on my own. Then obviously what now? The faculty who is teaching for 10 years, then definitely they will tell what now? Student itself unable to what now? Tell this is I learned from so and so teacher now. They will not. Then obviously a faculty is working for 10-15 years now. So his ego will be there now. He cannot tell. So this is what now some of the teacher, some of the what they will not tell it now. Previously never I used to tell all this thing in my classes now. I used to teach directly now. But only last 2 to 3 years I forced to tell what now. I created all this thing. This was happened because of when I'm taking the generally made-easy. I started about a made-easy with machine design only. Then afterwards I shifted to strength of material almost from 2007 to almost 2017 or 18. First 10 years I used to teach both strength of material machine design for all the batches. But 2017 and 2018 the number of batches was increased drastically in Delhi now. So my time was not permitted to complete the machine design for all the batches now. Then one of my student, Mr. Padmesh sir, who is going to teach machine design for you, for all of you, he has started what a machine design now. Initially I used to teach for talent batches, remaining regular batches is to teach it now. But still as the number of batches was more, even the talent batches also Mr. Padmesh sir used to take it now. But I used to take the machine design only few centers, Hyderabad, because Hyderabad would generally 2 or 3 batches will be there now. So I can able to complete, but Delhi more batches will be there. If I can take one batch, then automatically the comparison will be there. So the management was not permitted. If you want, you can take all the batches for machine design. Otherwise, in Delhi, if you are going to take one batch, the students also remaining batches also they will ask. So then I accepted now. But engineering service mains I am taking machine design. Mr. Padmesh sir is taking the prelims point of view. Gate and prelims engineering services machine design, he will teach it now. Means I am going to teach it machine design. When I am taking the machine design for mains batch, maybe 3 years back, one of the students was asking now, sir, you're teaching the same information from Padmesh sir. अपने पद्मेश सर नोट से बता रहे सर हमको, आप बोल रहे सर, it seems to be you referred the Padmesh sir notes. I have not referred his notes now. He is my student. He has referred my notes. Because I am not taking the prelims, what the prelims point of I am not taking. So they assumed that sir is only for strength of material, machine design. He has referred the Padmesh sir notes now. I have not referred Padmesh sir notes now. He is my student. He has attended classes of machine design in Lord Sarai Center just like all of you now. So on that year onwards, and next Hyderabad also when I am taking this now. One of the student in what now? Sir, you have mentioned this year the same thing taught by, I attended a class in other center, other institute, other teacher also given now. He is my student now. So on that, because of these two reasons, the next year onwards, I used to clearly telling all this thing. I created. Otherwise, the students are assuming that I am referring somebody's notes now. I am not referred the anybody's notes now. They are all referring my notes. They are doing the modification. They are changing my name. They are doing all this thing. I am not referred the anybody's notes now. When I started my profession, these are all what now? Still they have not entered into what now? They may not complete it. There was when I started my profession now. They were maybe 7th or 8th class will be there now. And some were not born also by the time now. My student is teaching what I am almost 53. He may be teaching 25 means what now? When I am teaching what now? When I started my teaching profession, he was not born also. And he is going to tell what now? He is referring my notes. He is telling what now? I created now. So because of these reasons, and especially during this COVID period now, so many institutes online are going to be there. They're all what are reproducing. So because of only once I am telling now, I am not referred anybody's notes. So they're all referred my notes. I'm not referring anybody's notes now. So this I am telling for the last 3 to 4 years because of this problem now. If I don't tell it, they are assuming that what now I am referring somebody's notes now. So we are going to discuss all these loads. If I am going to complete a one batch, today I am going to start with the evening mains batch machine design. I am going to teach it now. Then the faculty who is teaching machine design, they are going to wait now. When the sir is going to teach the mains machine design and what are the new points is added, and they will contact with the students and they will ask the students to send the PDF copy of the Krishna sir mission design notes. Then they will refer it now. If I add a one point, that is going to be reproduced in the next batch now. Or when the sir is going to complete the strength of material this year 2022-23 batch, what the new points is added, what the new problems are added, and they are going to reproducing now. They are going to reproduce it, but I'm going to change it now. Batch to batch, my notes is going to be changes now. So today your class may not be up to 3 o'clock, because at 5 o'clock I'm having a mains batch is going to be there. So today maybe 2 o'clock or 2:15 we'll try to close it, because so I have to go to my home and I have to finish my lunch, and once again I have to come to the Medici at 4:30 to start the mission design for the mains batch now. When you are going to attend the mission design classes, in mission design there you are going to get so many comparison tables are going to be there. They are not from any of the textbooks. Whoever is giving the table means 100% is going to be my notes only. There are so many differences will be there now. Hydrostatic, hydrodynamic lubrication, journal and anti-friction bearing comparison, key and quarter difference, clutch and coupling differences. So there are so many comparison table will be there now. They are not from any of the textbooks now. And difference between a shaft, axle, spindle. So many comparisons are going to be there now. So they are all not from any of the textbook. When I started my profession 1994, I've already mentioned I was fortunate to be associated with one of my great teacher. We used to sit it now. In the midnight 2 o'clock or I used to go to my teacher's one with this one. We used to sit it and we have prepared the tables now. But afterwards I modified it now. So used to be I worked before that one. I worked in 1.5 years in the industry now. So by using my little bit of industrial experience, so I used to sit it with my teacher, either a more expert, but both we prepared the tables now, comparison tables now. So for your study, the comparison between stress and pressure, comparison between your ductile and brittle materials. So now to discuss, when I'm taking one example here. This is a shaft, these are the bearings. This blue color one are the bearings. And this is a pulley with a weight of W. Assume W2 is the weight of the bearing, W2 is the weight of the bearings, and the shaft. And shaft weight is W1. Pulley weight is W. Now, when I am designing the shaft, first question will now? when you are designing the shaft, that is when you are calculating the diameter of the shaft, when you are calculating the diameter of the shaft, which weight, there are three weights are there. Weight of the shaft is W1, weight of the pulley is a W, and weight of the bearing is W2. So with respect to shaft, out of these three weights, which one is considered load now? Now if I draw the side view, shafts are horizontal. Is the cross section of the shaft. The shaft. This will be without a pulley. This is a pulley. This is representing the pulley. This is about a shaft. So what this red color circle now? Cross section of the shaft. W is about the cross section of the shaft. Sorry, red color about the cross section of the shaft, and W is the weight of the pulley. Shafts are circular. Shaft is a horizontal. We can see the cross section in side view. Is the side view for the pulley. Now, first question is what now? When you are designing a shaft, out of the three weights, which weight will become as a load now? Pulley weight. Self weight is neglected because it is a distributed load. The weight of the shaft is distributed over its entire length. How to get the weight of the shaft? Now W1 gamma into what the area of this? Now pi by 4 d square and length of the shaft. So this W1 is given by gamma into pi by 4 d square L. D the diameter of the shaft, and W to the weight of the bearing. So here which weight is acting on the shaft now? Which weight is acting externally onto the shaft now? Pulley weight. So with respect to shaft, the pulley weight is acting externally. So this will become as a load now. With respect to shaft, pulley weight is considered as load. Considered as load. But which one is neglected now? Self weight is W1 is neglected. That is in design of shaft, you can put it like this now. In design of shaft, pulley weight is considered load, and W1, that the self weight, is neglected. because it's the self weight. Now same thing when you are designing a bearing. Now what the purpose of the shaft now? The purpose of the shaft is to support this pulley. The purpose of the shaft is to support this pulley. So pulley weight is acting externally onto the shaft. Now, but this shaft is supported by what? A bearing. Pulley is supported by the shaft, and shaft is supported by what now? Bearings. Now, when you are designing the bearing, in the design of the bearing, which weight should be considered load now? Which weight? I'm talking about only the weights now. In design of bearings, which weights are acting onto the bearing now? This shaft is supported by the bearing. Bearing is about now machine element for the bearing is a machine element for the supporting machine element. So weight of the shaft is acting externally onto the bearing. Already weight of the pulley is also acting on the shaft now. So how many loads are acting on the shaft? How many weights what should be considered now? W and W1. W and W1 as consider the loads. That is, W2 is neglected because of its self weight. Why you are neglected means what the answer is the unknown. When the dimensions of the bearing, design means you have to find out the dimensions of the bearing. When dimensions of the bearing unknown, weight, self weight is unknown. That's why it's neglected now. Now, can you tell me now which type of load it is now? So in the shaft, which weight is becoming the load now? W. W is becoming the load now. But how many loads you have studied now? Loads are what now? Based upon 3 parameters. Now what should I call this W now for which type of load now? So in design of the shaft, W is what? A consider load. Now which load I have to consider? There are so many loads you have studied now. So W should become as which load now? For shaft, W the which load now? How many classification is studied now? 3. With respect to time. With respect to time, how many loads are there now? Static load and dynamic loads. How many static loads are there now? Now this is what now? Static load means what now? Magnitude and direction is constant. Weight of the pulley is a constant or changes? Constant. So with respect to time, it is a static load. With respect to time is a static load. We have studied the 3 classification now. So with respect to time is a static load. What is the meaning of static load? Its magnitude and direction is constant. Weight of the pulley is a constant. But which type of static load? There are 2 type of static loads are there now. Dead load and gradually applied load. Is a dead load. Weight will not be changes. So dead load. Gradually applied load means what you have studied now. Its magnitude gradually increases now. But this weight is a constant. Once a pulley is manufactured, its weight is a constant. The which type of static load means what the answer now? That is dead load. Next. With respect to cross section, this is with respect to time, and with respect to cross section, how many loads are there with respect to cross section? Normal load and shear load. Now you can see now this is acting parallel to cross section of the shaft or what now? It is acting parallel to the cross section means a shear load. But which type of shear load? How many shear loads you have studied now? Just now you have studied the static load, but which type of static load? Dead load. And on a cross section, how many loads are there now? Normal load and shear load. But they are acting parallel to cross section or perpendicular, parallel. There was shear load. But how many shear loads are there now? TSL, ETSL and TSL, ETSL and twisting couple. It is not a couple. Therefore, either it should be a TSL or it should be a TSL or it should be a ETSL. Now this is what the passes through the centroid. This is centroid. So this is called the TSL. But this is along which axis now? VCA. This is what the HCA, this is the VCA. So this will become as about a VTSL. So with respect to shaft, with respect to cross section, it is a shear load. But which type of shear load? Vertical transverse shear load. Vertical transverse shear load. It is along which axis? No, this is the VCA. It is the HCA. And this is polar axis. Polar axis. VTSL. Or otherwise you can see now. Now this will be a longitude axis. What is the relation between these two? What is the axis and longitude axis? And the weight. What is the relation with the longitude axis of the shaft and the weight? Weight of the pulley, perpendicular intersecting. If the load is acting along this axis, axial load. But here how the W is acting now? We can two ways you can see it now. One is parallel to cross section, pass to the centroid. But it along which axis now? VCA. So the vertical transverse shear load. Otherwise you can see the longitude axis. This line is the longitude axis now. The longitude axis of the shaft. So what is the relation with the longitude axis and the load? Perpendicular intersecting. It is a TSL. But which type of TSL is acting along VCA? Vertical transverse shear load. Next, with respect to distribution. With respect to distribution, it is acting only on the. It is acting on what now? Multiple cross section or what now? Only one cross section. What are these dots now? What are all these dots you have studied now? Centroids. Centroids of each and every cross section. So this load is what now? Acting on the every cross section of the shaft or only one cross section? Only one cross section. What this dot is representing now? Centroid of the cross section. Now this is what now? Cross section here now. So this load, weight of the pulley is acting only on one cross section. There was a constant load or distributed load? Concentrated load. But which type of constant load now? Concentrated point load or constant moment? Concentrated point load. Some student, if I ask what is the W, somebody is going to say static load. Somebody is going to tell sir TSL. Somebody is going to tell the constant. But most of the students are going to tell constant loads. All are correct. Whoever is telling constant load, what they have to mention now? Sir, with respect to distribution is a constant point load. With respect to cross section is a transverse shear load. Which type of transverse shear load? Vertical transverse shear load. And with respect to time is a static load. But which type of static load? Dead load. So this is with respect to distribution of load. The load is acting only on the weight of the pulley is distributed only one cross section, concentrated loads. But what about the weight of the shaft? Weight of the shaft is this W1. W1 is distributed on each and every cross section. So what should I call the W1? With respect to distribution. With respect to distribution is a constant load or distributed load? Distributed load. UDL will be considered now. And this is with respect to cross section. And this is with respect to time. Static load is correct. Vertical transfer shear load is correct and constant point load is correct. One small request, thank you for all your, some of the friends, Mr. Narang and etc. Narang as well as Swaraj Pandey. My dear friends, please don't make it as about now strength of material God. So I'm a still student in this subject. Still I have to learn a lot in the strength of material subject. There are so many great authors are there in the strength of material. So that is my small request. So whoever is going to be what now? Definitely who is going to, I'm going to be very, very happy. I'm very, very happy if my efforts are useful in fulfilling your goal. I'm doing my efforts. That's all. If you are getting a success, the credit goes to you. You have believed me, you have believed yourself, and you have done the right action at the right time. About to ask, one of your friend is asking, sir, in design of shaft, pulley weight you are considered, self weight you are neglected, but what about the bearing weight, sir? If the doubt is what now? Everybody is going to ask these doubts now. I am about to ask this question, and one of your friend, Mr. Somnath Mandal, is asking the same question now. Sir, pulley weight is considered, self weight is neglected, but what about the bearing weight? Whose weight is acting on the now? Whether bearing weight is acting on the shaft or shaft weight is acting on the bearing. Whose weight is acting now? Shaft weight is acting onto the bearing, but bearing weight is not acting on the shaft. You are sitting on a chair. You are sitting on a chair. Your weight is acting externally onto the chair, but chair weight is not acting onto you now. The reactions are going to be there. I am talking about the only weights now. Pulley weight is not acting, pulley weight is acting on the shaft, and shaft weight is acting on the bearing. But bearing weight is not acting on the shaft now. Shaft is what now? Supported by the bearing. Shaft is supported by the bearing. Shaft is supported by the bearing. Means shaft weight is acting externally onto the bearing. Shaft weight is acting externally onto the bearing. But weight of the what now? Bearing is not acting on the shaft. But there are reactions are going to be there now. But timing I am considering only weights. 3 weights I consider now. Weight of the pulley will become as the load for the shaft. And shaft weight and pulley weight. Shaft weight and pulley weights are acting on the shaft bearing. Because which is supporting the pulley supported by the what of shaft. Pulley supported by the shaft. So pulley weight is acting on the shaft. And shaft and pulley are supported by the bearing. So shaft weight as well as what now? Pulley weight and acting on the bearing. So W means which type of load you have to give it now. W means somebody is going to give the static load. Which type of static load? Dead load, transfer shear load, constant load. So now what is the, so far you have studied this load now. Suppose the load is applied like this now. Suppose there is a load is like this now, P. Suppose the load is applied like now. This is which type of load now? Normal load. But which type of normal load? Axial load. But the axial load definition already have studied now. Axial load is a load along the longitudinal axis. Next, if there is one more load is like this. What this vertical line? What this blue color line? Cross section. And what about this dot now? Centroid. So what about this P and Q? P and Q are perpendicular to cross section. It is also perpendicular. It is also perpendicular. So with respect to this line is a cross section. Both the lines are perpendicular. They are normal loads. But which type of normal load? This will be passes the centroid, but this is away from the centroid. How many normal load you have studied now? How many normal loads you have studied? Axial load, eccentric axial load. But this will be an axial load. Axial tensile or compressive? Tensile. And Q is about now? Q is about now? Does not pass the centroid, is the eccentric axial load. Eccentric axial tensile load. Eccentric axial tensile load. Now, can you differentiate it now? What way P and W are different now? In what way the P and W are, this you are calling as what now? With respect to cross section of the shaft, is a transfer shear load. Which type of transfer shear load? Vertical transfer shear load. This is which axis now? You have studied already VCA and HCA, you have studied now. This is VCA. This is HCA. Now, what the difference between P and W? P is acting perpendicular to cross section is the normal load. But W is acting parallel to cross section. W is acting parallel to the cross section. This load. What this line now? Already yesterday the cross section yesterday. This line is the cross section. So what the P and R different now? P is acting perpendicular cross section is the normal load. R is acting parallel cross section shear load. So what the difference between P and R? Is a, but which type of normal load? Axial load. And this is going to be a transfer shear load. Is a transfer shear load. So what the difference between axial load and transfer shear load? What the difference between axial load and transfer shear load? Axial load is along the longit axis. Axial load is along the longit axis. But what about the transfer shear load? What's the relation with the longit axis and the transfer shear load? Perpendicular and intersecting. Perpendicular and intersecting. And what about this Q now? Is a normal load. But which type of normal load now? Eccentric axial load. Eccentric axial load. So what's the difference between P and Q? P is along the longit axis, but Q is what now? Parallel to longit axis. P is along the longit axis. Q is parallel to longit axis. So once you know longit axis, now how to answer it now? Assume this is the longit axis of the shaft now, and this is a pen. This is what now? Load. This is along the longit axis, axial load. This is what a Q. Q is what a parallel to longit axis, eccentric axial load. And this is R. R is what now? What the relation between the R and the marker now? Perpendicular intersecting. So once you know longit axis, how to you can easily tell it now. When the line of action of the load is along the longit axis, when the line of action of load is along the longit axis, is an axial load. Parallel to longit axis, eccentric axial load. Perpendicular and intersecting. Perpendicular intersecting. Perpendicular intersecting is about a transfer shear load. With respect to cross section of the shaft, what the P? P the axial tensile load. This already I studied now. What the Q? Eccentric axial tensile load. R and W are vertical transfer shear load. This is along the long ATL, axial tensile load. Eccentric axial tensile load. Vertical transfer shear load. This will be along the longit axis of a member. When the load is acting along the longit axis of a member, axial load. Parallel to longit axis, the eccentric axial load. Perpendicular and intersecting the longit axis. Perpendicular intersecting the longit axis, transfer shear load. This is parallel to longit axis, and this is perpendicular and intersects. Perpendicular and intersect the longit axis. Anybody, what about this S now? What this vertical line cross section? Already I studied now. Cross section. Now what about this S now? What is the meaning of inclined line you have studied now? Perpendicular and inward. Perpendicular inward, like this now. This is a S. Now what the relation between the marker and the longit axis? What the relation between the marker and the longit axis? Perpendicular, but they are not intersecting. It is the eccentric transfer shear load. This is what now? This is the marker is the S. But in the figure you are showing like this now. So what the relation, the marker and the longitude axis perpendicular but they are not intersecting. So it will be called as what now? Eccentric transfer shear load. Eccentric transfer shear load. Now if I am going to show only the 3D figure here now. If we draw the pictorial, this is now. This is what the centroid you have studied now. This is which axis you have studied. HCA. This is always the 3D figures are for better to understand now, but mostly they are going to give the 2D figures. This is VCA and this is polar axis. All the basics here, definitions you have studied now. Is the centroid. What is it representing now? Cross section of shaft. Left side. Now, can you show this force? Now, this is a P. P. Now, P is the which load now? Normal load or shear load is the cross section. Is a normal load or shear load? Is a normal load. How do you know normal load now? It is along which axis? The polar axis. Polar axis always what you have studied, perpendicular to cross section and passes the centroid. So it is along which axis? No, ZZ. Therefore it is what now? Normal load. But this normal load passes the centroid or away from the centroid? Passes through the centroid. And the tensile load away. So it is going to be what now? Normal load. But which type of normal load? How many normal load on the cross section now? 3 loads. One axial load, one eccentric axial load, one bending couple. But the axial load, axial tensile or compressive? Tensile. Next. What about this now? What the Q? What the difference between P and Q? What the difference between P and Q? Both are perpendicular cross section. But this is passes the centroid, this is away from the centroid. So both are normal load only. But this normal load on the cross section is called the axial load. And this is what does not pass the centroid. It is a eccentric axial load. So how to differentiate these two loads now? If somebody asks now, what the difference between axial load and eccentric axial load? What the similarity between both this now? Both are normal loads. But what the difference now? First difference is what now? It is a perpendicular to cross section and passes the centroid. But this is perpendicular to cross section but does not pass the centroid. Next. This is along the longitude axis. This is along the longitude axis. And this is parallel to longitude axis. So what the difference between axial load and eccentric axial load? Axial load is perpendicular to cross section, passes the centroid. Eccentric axial load perpendicular to cross section does not pass the centroid. Eccentric means always it will not pass the centroid, away from the centroid. Or what the other difference now? Axial load is along the longitude axis and this is parallel to longitude axis. But both are tensile load will be there now. Next. This is that weight of the pulley example, weight of the pulley now. This W is similar to here now. Now what this R now? Is a parallel to cross section or perpendicular cross section? Parallel. So what the difference between P and R? In what way this R differ from these two now? These two are what? A perpendicular to cross section, but this is parallel to cross section. Is a shear load. But which type of shear load? How many shear loads you have studied now? Transfer shear load, TSL, eccentric transfer shear load, and twisting couple. It's not a couple. So either it should be a TSL or ETSL. Now this is what? A pass to the centroid or away from the centroid? Passes to the centroid. This dot is about now centroid. So it is about a transfer shear load. But along which axis? Na VCA. So the vertical transfer shear load. Vertical transfer shear load. And what the relation with the longitude axis and the R? What the relation between these two? Perpendicular. So can you differentiate axial load and transfer shear load? Axial load is perpendicular to cross section and passes the centroid. This is parallel to cross section, both are passes the centroid. But this is perpendicular and passes the centroid. This is parallel and passes the centroid. Next, what the other difference now? This will be axial load is along the longitude axis, but transfer shear load is perpendicular and intersecting the longitude axis. What the relation with the longitude axis and the R? Perpendicular intersecting. Next. What the difference between R and T? Both are parallel to the cross section. Both are parallel to the cross section. Both are past the centroid. But this will be what now? R is along VCA. T is along HCA. So it is also shear load. It is also shear load. But how to differentiate it now? It is also transfer shear load. It is also transfer shear load. But this will be along VCA. It is a VTSL. This is along HCA. HTSL. Horizontal transfer shear. This is very important for mechanical engineers now. Next, what about S now? What the difference between T and S? What the difference between T and S? What the difference between T and S? T is passes the centroid, but S does not pass the centroid. But T is along HCA is a horizontal transfer shear load. But this is shear load only, but does not pass the centroid. It is about now eccentric transfer shear load. But this is parallel to which axis now? HCA. It is parallel to HCA. Therefore, it is called as about now horizontal transfer shear load. Horizontal transfer shear load. What about U? U is also parallel to cross section but does not pass the centroid. It is also TSL. But which TSL? ETSL does not pass the centroid. ETSL. But what the difference between R and U? R is passes through the centroid and along VCA. But U is parallel to which axis? VCA. So it is a vertical transfer shear load. Vertical transfer shear load. So on this cross section total, how many loads here taken now? Q, P, T, R, S, U. How many normal loads are there now? P and U. Normal loads are on this cross section. What are they now? I am writing with respect to this figure. How many normal loads are there now? P and Q. But P is which type of load now? Axial tensile load. Q is what now? Eccentric axial tensile load. Next. Shear loads on cross section. One is R. T. S. All are parallel to cross section. But how many are past the centroid? R and T are past the centroid. So these two are called as what? When is past the centroid is a TSL. But this along VCA, so it is a VTSL. This along HCA, HTSL. So this will be a VTSL, vertical transfer shear load. All the beams are subjected to vertical transfer shear load. So most of the strength-o-meter textbook, they are discussing this only. Mostly beams are subjected to vertical transfer shear load. But machine components are subjected to both vertical and horizontal transfer shear load. T is along HCA. If you don't know HCA, VCA, I cannot help now. Already I discussed everything now. HCA, VCA, polar axis are all I discussed now. But those who are not gone through that, for them it is going to be what now? Uneducated persons watching a what now? English movie. Or a North Indian is what now? Watching a South Indian movie without any titles now. Each and everything I have explained now. Sir, what the HCA, sir? What the VCA, sir? What the polar axis? I'm not going to repeat so many times. I already have studied definitions already written now. But will not refer that. Some of the friends I'm talking about now. Not everybody. 10% category will be there now. 10% of the students' behavior will be in my classes just like what? An uneducated person watching a English movie. Or a North Indian is what now? Watching a South Indian movie without any titles. Or a South Indian is what now? Especially some South Indian what now? They don't know any Hindi now. Some states of South India what now? So they are very weak in Hindi now. And he is what now? Watching a what now? He is having a very close North Indian friend is there. And this North Indian friend is taken this South Indian friend to a what now? Hindi movie. And this North Indian movie, what a friend is what now? Enjoying the movie like anything now. But the South Indian friend is what now? He don't know what the alphabets of Hindi. Either just like a every 5 minutes, the friend is what my friend is what enjoying. I'm unable to enjoy the movie. Every 5 minutes he'll go outside and he'll come inside now. So those who are already attended now, those who have gone through the notes, they are going to be cleared. Generally, one of the batch now, when I'm taking the 3-4 years back now, one of the friend is what now? Every 15 minutes, 20 minutes, he'll go for the washroom and he'll come back now. Why you are going like that means, sir, आपने तमिल लैंग्वेज में पढ़ा रहा है सर, मुझे तमिल नहीं आता सर. I will use only Hindi, English words only. I never use what there are different categories of going to be here. I'm going to use the simple English. And he's telling what, sir, you are explaining in what a Tamil language, sir. I'm unable to follow Tamil, sir. But all your friends are, sir, they know Tamil, sir. They're all what, mostly they are going to be what now? Sitting in what most of the Delhi offline batches are what mostly 50% are going to be Uttar Pradesh as well as what now? Bihar will be there now. and it's telling what he is unable to what identify which language used by the teacher, and it's telling what now sir आपने तमिल language में बोल रहा है sir, because he's not attend the classes regular, he is not focused about the classes now, and he has not referred the notes, then everything is going to be what now new for him now, and every 10 minutes 15 minutes will go outside and will come back now. Sir, yourself and my friends are communicating in a foreign language, sir, but I am unable to identify which language you are using. My friends and yourself are communicating in a foreign language. Because some students are what, sir, what the VCA, what the HCA will be there now. And what about S now? S is not past the centroid away. Whenever it is away from the centroid, it is a what now? Eccentric load. But the parallel to cross section are perpendicular. This is what now? It is also not past, Q is also not past the centroid. S is also not past the centroid. But this is perpendicular to cross section. Then this is the eccentric axial load. But this is not past the centroid, but the parallel to cross section. It is the eccentric transfer shear load. But the parallel to which axis now? This S is parallel to HCA. Therefore, it is about now horizontal eccentric transfer shear load. Horizontal eccentric transfer shear load. What about U? U is also not, but R is past the centroid, but U is not passed away from the centroid. So it is also TSL. But this is parallel to which axis of VCA. So the vertical eccentric transfer shear load. Vertical eccentric transfer shear load. You are correct, my dear friend, Mr. Supreet. For top surface, it's going to be a shear load, but we are all discussing with respect to cross section. There is no longitudinal load and no axial load, my dear friend. Somebody is asking Akshay, sir, what is the longitudinal load and axial load? There is no longitudinal load. Who mentioned the longitudinal load? Never I use the longitudinal load. Where you have come across that word now? There is no longitudinal load. No longitudinal load. It's the incorrect terminology. So now, can you tell it now? With respect to cross section, these loads can be defined two ways now. These loads can be defined two ways or three ways. One is with respect to cross section. Now with respect to cross section, what the axial load now? With respect to cross section, what the axial load? Perpendicular to cross section passes to the centroid. I'm going to write down this also. I'm taking now. With respect to cross section, what the axial load definition now? Axial load is a load which is perpendicular to cross section passes to the centroid. And what about the eccentric axial load? Eccentric axial load is a load which is perpendicular to cross section but does not pass through the centroid. And what about transfer shear load? Parallel to cross section, pass through the centroid. It is also transfer shear load. It is also transfer shear load. Both are parallel to cross section, pass through the centroid. Next, what is the eccentric transfer shear load? Eccentric transfer shear load is parallel to cross section but does not pass the centroid. Eccentric means always away from the centroid. So axial load is perpendicular to cross section, pass the centroid. Like this, now my hand is the cross section, is the centroid. Now this will be this is the HCA. Is a VCA, and this dot is the what now? This dot is a polar axis or centroid. Now this is a cross section. So whenever a cross section is given, what do you have to do it now? Like this. Now what is this pen now? Just like P there now, P. Previously cross section is like this. Now for understanding purpose I am rotating like this now. So this is what now P. So P the what? What the relation between my hand and the pen? Perpendicular and pass the centroid. It is the axial load. Axial load. And what about this load now? This is also normal load, but does not pass. What the relation between the pen and my hand? Perpendicular, but they are not pass. This is not pass the centroid. It is the eccentric axial load. Eccentric axial load. It is also eccentric. What the relation between this pen and my hand? Perpendicular and not pass the centroid. The eccentric axial load. Next, what about this now? This will be R. R is what? The parallel to cross section, pass the centroid. Parallel to cross section, pass the centroid. Is a vertical transfer. Is a along VCA. Vertical transfer shear load. And this is what now? T. Parallel to cross section, pass the centroid. Is the HTSL. HTSL. Is along HCA. Next. This is what the S. This is S. It is a parallel to cross section. It is in my hand now, parallel to cross section. But pass the centroid or away from the centroid is the eccentric transfer shear load. But it is parallel to which axis now? HCA. This is what now? Horizontal eccentric transfer shear load. Horizontal eccentric transfer shear load. Next, this is what now? U. Still is a parallel to cross section, but does not pass the centroid. It is a ETSL, but this is parallel to which axis now? VCA. Is a vertical transfer shear load. Eccentric transfer shear load. P the axial load. Q the eccentric axial load. R is about a VTSL. T the HTSL. And this is what now? Horizontal eccentric transfer shear load S. And this vertical eccentric transfer shear load. So once a cross section is given, directly you can tell it now. First, is it perpendicular or parallel? Perpendicular means normal load. And if that load passes the centroid, is the axial load. Perpendicular does not pass the centroid. It is a eccentric axial load. Parallel to cross section, passes the centroid, is a TSL. Parallel to cross section, passes the centroid, is a TSL. But if along VCA is what? A vertical transfer shear load. If it is along HCA, the horizontal transfer shear load. Parallel but does not pass the centroid. It is a horizontal eccentric transfer shear load. Parallel to cross section, does not pass the centroid. Eccentric transfer shear load. If it is parallel to HCA, is what? A horizontal eccentric transfer shear load. Parallel to VCA, it is about now vertical eccentric transfer shear load. But sometimes longitude axis is given. If a longitude axis is given, simple now. Now you can just now you studied now. Axial load is along the longitude axis. VTSL is what now? VTSL is what now? TSL is perpendicular to longitude axis. If a longitude axis is given, this is a longitude axis of the member. is a load. This is along the longitude axis axial load. Parallel to longitude axis eccentric axial load. Parallel to longitude eccentric axial load. This is perpendicular intersecting. Perpendicular intersecting. It is a transverse shear load. Transverse shear load. And what about this now? This pen is about the longitude axis. This is a load. Both are perpendicular. They are not intersecting. Is a eccentric transverse shear load, just like U. These both are perpendicular, but they are not intersecting. It is about the transverse shear load or eccentric. Transverse shear load means what? This is a transverse shear load. Perpendicular intersecting. It should intersect the longitude axis means what the condition now? It should intersect the longitude axis means it should pass through the centroid. What the longitude axis you have studied now? Imaginary line joining the centroids. So transverse shear load always intersect the longitude axis. But this U is what? Not pass through the centroid. U is not pass through the centroid means what now? U is not pass through the centroid means away from the longitude axis. Longitude axis always pass through the centroid. So if a longitude axis is given, what the answer now? Along the longitude axis axial load. Parallel to longitude axis eccentric axial load. Perpendicular intersecting is what now? Transverse shear load. Perpendicular does not intersect with the eccentric transverse shear load. So I have drawn the what now? With the 2D figures I explained. With a 3D figure I explained. And I taken my hand. With the pen I explained now. So loads can be what? Defined. Loads on the cross section can be defined what? Either with respect to cross section or longitude axis. Otherwise HCA, VCA like this now. This will be what? Axial load is along which axis now? Polar axis. Axial load is polar axis. This is what now? Parallel to polar axis. What about this now? Parallel to along VCA is along HCA. This is parallel to HCA, parallel to VCA. So loads can be defined three ways now. Either with respect to cross section or longitude axis or HCA, VCA, polar axis. Three ways you can define it now. So whatever I discussed after break, somebody is asking to explain it, continue it, but I will give a what now. Today there is not half an hour break, only what now, because the class will be around 2:15. I will close it. So I am going to give a break. It is 12:20. Now I am going 20 minutes break. I am going to give it. So after break, I am going to show the whatever I discussed for your reference. I will write down on the table now. Bending couple and twisting couple already I studied. That need not be explained. Bending couple and twisting couple. On the cross section, 6 loads are going to be there now. Already 4 forces and 2 couples. What are the 4 forces now? Axial load, eccentric axial load, TSL, ETSL, and 2 couples. What are the 2 couples now? Bending couple and twisting couple. Externally can apply it on a cross section 6 loads. Out of them 4 are the forces and 2 are the couple. What are the 4 forces now? Axial load, eccentric axial load, TSL, ETSL, and 2 couple. Bending and twisting couple. Out of them 3 are normal load. What are the 3 normal load? Axial load, eccentric axial load, and bending couple. How many are shear load now? Transfer shear load, ETSL, as well as what now? Twisting couple. So we'll take a break. After break, we are going to continue it now. Thank you. So now you can relax for 20 minutes. So we'll continue after 20 minutes now. Thank you.